Okay. Chapter 3 is when we are going to get into logic. So kind of similar to sets. Actually, there's a lot of similarity to sets. But in language in particular, there's a very important focus on the difference between and or and if-then statements. And this is very much something that people who are good at arguing, lawyers, I guess mathematicians also have to argue whether or not their proofs are correct, but they're quite good at it. They maybe don't have to do what we're going to do with writing things down and then translating them and writing the logical equivalences, but probably they had to at some point to learn how to do that so that when they were able to kind of build up to the point that they're at of where they can kind of just do all of this in their head, or if someone says a statement, they can think, okay, what is that actually saying? And so that's what we're going to do. We're kind of going to set the building blocks for logical arguments, and we're going to be very, very specific on what things mean, what's a statement, what's if then, what is equivalence, and all of these things. So starting with the definition of a statement, this is kind of like when we started out with sets, we talked about the definition of a well-defined versus a not well-defined set. Very similar with logic. When we're doing these logic tables, these truth tables, we have to talk about statements. Because if we're not talking about statements, we can't really determine if something is true or false. And so a really good example of something that is not a statement is an opinion. So someone could say something and maybe you agree with it, but that doesn't necessarily make it true or false. Or you could have a question. That's not a statement for obvious English reasons. You could just say something vague that wouldn't really, well, I guess maybe if you're careful with vague, but vague to the point where it's not really clear what you are saying and whether or not someone could say that is true or that is false. I suppose technically a vague statement, as long as it's phrased correctly, could be a statement, but it has to be something that objectively anyone could come up across it, and maybe they would have to do a little bit of research, but they could say, yes, that is true, or no, that is false. So for example, well, I guess we're just going straight into things. We have two statements here. Shakespeare wrote the television series Modern Family, and today is not Monday. And notice here that we're not really talking about whether or not a statement is true or not. We are just trying to say, this is the statement. In this case, A is definitely false, but it's still a statement. And so since it's a statement, we can write the negation of it. So Shakespeare wrote the television series Modern Family. We think that's false. So maybe we want to write a true statement. And so the very first thing we're dealing with is this negation. Well, it's kind of the not of the logical equivalences. So you would say Shakespeare did not write the television series Modern Family, or someone said that today is not Monday. Well, the negation of that would suppose technically would be today is not Monday, but that doesn't make any sense. So we would just say today is Monday, which fortunately it is when I'm recording this. And so when we're doing these symbols, we like to kind of give statements almost like a variable that we're associating with it, because it's kind of, I mean, it's not that bad in this case when we only have one statement, but later on we're going to have situations where we have 4 or 5 statements flying around, and we're going to try and manipulate it. So instead of rewriting the sentence again, or statement again and again and again, it's nice to just say, okay, the first statement is P, the second statement is Q, and so now I can kind of write some symbols involved with it that is also shorthand. So that tilde, the wavy guy, is not. So instead of writing A as Shakespeare did not write the television series Modern Family, in mathematics we could just do tilde P, and we're done. So tilde means not. And as I was saying, the statement can be defined as a variable or as a letter. So here are some kind of statements that are called quantified. And we can have quantities when we're dealing with statements. Some, all, none, every, even though they might be true or false, typically, as long as they're phrased correctly, as long as they're not questions, as long as they're not opinions, they can be assigned true or not. For example, all people are happy. well, that's the true or not true statement, but it's just to quantify. We're talking about a group of things versus a singular thing. And so here are a couple of statements. Here are a couple of equivalent ways to say them, and here are some examples of that. So when I'm talking about all A are B, there is a little bit more convoluted way of saying that there are no A that are not B. Those are saying the same things, oddly enough. And so to kind of see what that looks like, if we take a statement, all poets are writers, an equivalent statement would say that there are no poets that are not writers. It's a little bit cumbersome, but it's the same thing, it's saying the same thing. Same thing with some A are B. The negation of that is there exists at least one A that is a B. Now, maybe your brain's kind of having PTSD with this situation, because we did talk about things like this when we were doing probability that people were kind of struggling a bit with, but that's the idea, is we can kind of express things in different ways so that we have that logical equivalent. So some people are bigots. The negation of that is that at least one person is a bigot. No A are B, all A are not B. So no common colds are fatal, all common colds are not fatal. Which again, I don't think that's true. I think some are, but that's an aside. Some A are not B, not all A are B. Some students do not work hard, not all students work hard. Again, the English version seems, or the first statement is probably something we would use more often in English, but that does not mean that it's not equivalent. Wow, that's a lot of nuts. But that doesn't mean that the second statement is not the same thing as the first statement. Whew. Logic. So some negations of statements. So if I say all A are B, the negation of that is that some A are not B. So an example of all people take exams honestly, well, negation, some people do not take exams honestly. So we took a statement, we took the negation of it because it probably didn't really seem true, and now we have this negation, which gives us the opposite, so to speak, of all A are B. And then if we have some A are B, then the negation is that no A are B. So some roads are open. Well, the only time that wouldn't be true is that if every road is closed or no roads are open. I think, oh, these are just more examples. I'll pause for a second for you guys to read over it. I don't really want to read over it because it's very similar to what's the table right above it. Or I guess you could maybe pause and read over it. I don't really need to pause. So if we have to kind of put this into practice, we've been running through a lot of definitions, and unfortunately that is kind of the first two sections or so, but we can put it into practice here. So a mechanic told me that all piston rings were replaced, and someone later told me that he's always lying, or he's certainly lying to you in this instant. What can I conclude? So he said all piston rings are replaced. Well, we have to take the negation of that statement, and the negation of that statement would be that some piston rings were not replaced. So that's kind of the first row in that table that we can see. And that's another reason why these tables are kind of nice, is you can see, relate some statements that you might see, tie it back to this table and find the negation, because it's something that it feels like we've done logic our whole life. We've said things and we've said the opposite of things, but now we might have to retrain our brains a little bit to be clear and straightforward when we're dealing with these statements, to talk about, okay, well, all piston rings were replaced. You might say that the opposite of that is no piston rings were replaced, but that's not true with quantified statements. The only way, or the only thing that needs to happen for that statement to not be true is not all of them are not replaced, it's that some of them were not replaced. So watch for that. And maybe, I think I mentioned that I'm going to allow kind of 2 note cards for this exam, but kind of take a running tally of these tables and say, okay, I use this table a lot, I should probably include it on my note card for my exam, versus Okay, we saw this table for examples of negations, but I've gotten pretty good at negations by the end of this chapter, so I don't really need to copy over all of these tables, all these examples. That's it for this section.